wondered how computers see things, how modern machines track and detect things? Well, it's called computer vision. But before we explain it, first some revision. Fundamentally, images are made from pixels arranged in rows or columns. If we want to examine a few of these, there's a few operations that make it a breeze.
Does a computer see? It's not easy. These are the basics. Please bear with me.
The word convolution might give you a scare, but it's actually simply a way to compare a pixel to its immediate neighbors by multiplying their values with a kernel and adding together the sum of this mixture, then storing the value in another texture. A simple example of how this can work is a Sobel filter, which finds image edges. Essentially, an edge can be found when we compare the difference of pixels around our central pixel. If the difference is large, then we have an edge. Take a sec to recharge. Much like edges, there are also corners. These can help us because they have a rotation. They also have a center position. This makes them good for feature detection. Another concept that we use to help us is a normalized cross-correlation. It is simply the difference between the pixels of any two images squared then normalized. Use it to check if a part of an image looks similar to some other image.
Does a computer see? It's not easy. These are the basics. Please bear with me.
One more core concept worth explaining is something called half features. What are they then? The idea is that some square bit of image is darker than some other square, and this is the main thing used for face detection and a sort of a tree for optimization. That's enough about the core ideas. How do we use them for useful things? Well, convolution is one of the ops used for effects in Photoshop. Corners are used for natural features, which are used in a system called SLAM in robots. By tracking these features and how they all move, it's possible to calculate a point cloud and use that to work out the location of our camera, handy for VR devices. Hell yeah, we already talked about face detection, but detection itself is different from tracking. We're tracking an object in a short duration. We can follow movement using cross-correlation. This works for any type of object. It's faster than when you have to detect it. There are loads more things that we could learn. This is just a short start at a